In this video, I'd like to demonstrate an implementation with LucidLink and a message passing interface MPI cluster. I have created a file space called cluster, which I'll link to now. And when we open up the file space, we'll see the data set that we're working with. So now that we've connected to our cluster file space, this is the data within our cluster. The file space contains a contact data file, which is 1 million records of contact data. To define the cluster environment, I have 5 machines in my MPI cluster. At the moment, as you can see, the machines aren't consuming any CPU utilization, or network traffic is reasonably low. So I'll show you the environment within the cluster. We have our Lucid file space connected, and we have our mount point on our first cluster node, which we'll be administrating the MPI cluster from. If we connect to one of the other cluster nodes, we'll connect to cluster 1. We can see that it also has the Lucid mount point. If we connect to cluster 2, we can see it also has the Lucid mount point. And for good measure, cluster 3 as well as cluster 4. Let's change into our cluster file space on our main cluster node. And we can see our files that we highlighted when we joined on the local Windows machine. So we've got our Linux machine hosts that are seeing all the same data. We have a MPI program that is on each node going to read a random record contact from our contact file and write its choice back to a file based on its IP address. So if we look at the process we're going to use, the arguments are cluster worker, number of passes, and number of processes. So in this first example, because we know we've got 5 machines, I'll do 1 pass with 5 machines. So now we can see that we have 5 individual choices from our data set. If we have a look at our directory structure now, we can see that they have all written their own individual choice to a text file. So if we look at one of those text files, we can see process 2 out of 5 was this choice, and process 2 out of 5 was this choice. If we run the process again, we can see a new choice for process number 2, and we'll have a look at its text file to confirm that it has captured that. So we're reading from the Lucid mount point and writing to the Lucid mount point. The Lucid mount point is back-ended by an S3 bucket, so the data set across all nodes is reading and writing from the S3 bucket through our log-structured distributed file system. Now, I have my machines that have 0 utilization or close to, less than 1% utilization. I'm going to run the process 50 times across 1,000 processes. So this will lead to, each time it runs, 200 processes per cluster host member. So if I run that now, this will take a while, so I'll fast forward at this point. Okay, so now that our cluster hosts have finished processing 1,000 processes 50 times across the MPI cluster, we'll take a look back at our metrics of our resource utilization, and we can see that every node hit around 80% CPU utilization. There was no disk activity. There was only network activity because they were talking directly to the S3 object store through Lucid. So the benefits here are the MPI cluster enables you to work directly from a distributed architecture in or from cloud computing machines that traditionally have to talk to an NFS mount point in order to process an MPI job, or have to work out of in-memory data sets. So let's look on our Windows machine at the data outputted by our Linux cluster hosts. We're expecting to see inside these files that the machines have made their choices out of the data set, and we can see they've made 10,003 entries of their unique choice. If we look at another machine, we can see that its choices are reflected, and we're able to review the data that was outputted by a Linux process on a Windows or Mac OS machine. Thank you.